Another concept we need to understand on time series is the concept of seasonality. In this part, I will show you how to develop a forecast on time series that has seasonal pattern. To the extent that seasonality exists, we need to incorporate it into our forecast models to produce a better or a more accurate forecast. In this video, we will consider a seasonal time series without trend and with trend. This is an example of a seasonal time series without trend. It looks like a horizontal pattern showing no significant shift or no significant upward or downward movement. But it is very distinct that the quarterly pattern is repeated every year. On the other hand, a seasonal time series with trend looks like this. There is an upward shift of the data and the seasonal pattern is repeated along the trend line. First, we're going to calculate a forecast for seasonality without trend. For this case, we have a 5-year data of sales divided into quarters. The first objective is to calculate the seasonal indices of the time series. The seasonal indices is given by the formula SI is equal to average of the quarterly data of the time series divided by the average of all the data in the time series. The seasonality aspect of the time series is captured through the seasonality index. So we're going to produce a seasonal index for every quarter and then make use of these indices to make the forecast on the 6th year. Using the formula for quarter 1, the numerator is the average of the quarterly data of the time series. So we need to take the average of all the first quarter data. Divided by the average of the entire time series. So our seasonal index for quarter 1 is 0.9932. And we apply the same procedure for the seasonal indices of the other quarters. So here are the seasonal indices of every quarter. The value of the indices implies that for quarter 1, it's around 99% of the average quarterly forecast. On quarter 2, it is around 128% of the average quarterly forecast. Quarter 4 is around 97% of the average forecast. And quarter 4 is around 76% of the average quarterly forecast. And now we are ready to make a forecast for year 6. For instance, on year 6, it is expected that the total annual sales is 600 units. Therefore, the quarterly sales average is equal to 600 divided by 4 quarters. That's equal to 150. And from here, we're going to make a quarterly forecast using the seasonal indices. So for quarter 1, we're going to multiply 150, the average quarterly sales, times the seasonal index of quarter 1, which is 0.9932. Therefore, our forecast for quarter 1 of year 6 is 148.98. And we do the same for quarter 2 to quarter 4. On year 6, with the forecast of 600, it is expected to have a quarter 1 sales of 148.98, quarter 2 is 191.51, quarter 3 is 145.37, and for quarter 4, 114.14. On this set of data, we're going to make a quarterly forecast for year 5 using the concept of seasonality with trend. So the first part is to make the trend line using this data. First is to produce the equation of the trend line. So we're going to convert these periods into their corresponding time indices. So we have 4 quarters and 4 years. So our time indices is from 1 to 16. The time indices will represent the X values of the trend line. And the column of sales will represent the values for Y. For the values of the slope and the intercept, we'll make use of the slope and intercept formula of Excel. So for the slope of the line, that's equal to slope, known Y values, which is the sales data, and the known X values are the time indices. The slope of the time series is equal to 0.18. And for the intercept, that's equal to intercept, known Y's are the sales, and the known X are the time indices. The intercept of the regression line is 4.85. Therefore, the equation of the trend line, Y equals 0.18 times X plus the Y-intercept 4.85. This will be the equation we're going to use in order to make a forecast for period 17 to 20 of year 5. And using the trend line, the forecast for year 5 are as follows. And now we are ready to calculate the seasonal index of every quarter. The seasonal indices is calculated similarly as the seasonality with no trend. So here are the seasonal indices of this time series. And to incorporate these seasonal indices to our forecast of year 5, so this is our forecast using the trend line. What we're going to do is we're going to multiply each of the indices to their corresponding quarterly forecast. So for year 17, that's quarter 1, we're going to multiply 7.91 to its corresponding quarter 1 index. And our forecast for first quarter of year 5 is 7.10. So this will be our quarterly forecast for year 5. And to visualize the forecast accuracy of this method, we're going to graph the forecast alongside with the actual time series. As you can see in this graph, the blue line is the actual time series. And this orange line is the forecast using the trend line. And using the forecast of the trend line and incorporating the seasonality index, the result would be the gray line. As you can see, the seasonality with trend forecast is very much similar or was able to capture the movement of the actual time series. And this pattern is incorporated for our forecast on the year 5. So this is our first quarter forecast, second quarter, third quarter, and fourth quarter forecast of year 5.